Hey everybody, Mr. Rubo here, and today we are going to talk about being able to use and apply trig functions to find missing angles and sides of right triangles. So um, it is a little bit of review. Um, so let's, sorry about that, just get situated here. Uh, so First thing with the review is just remembering how triangles are named. So we have a right triangle here, say B and C. So the capital letters are your angles. The lowercase letters across from each angle is just the typical way of naming them. If we're looking though at, let's say, angle A here, so this angle here, this side would be its opposite, this side would be its adjacent, and then this side would be its hypotenuse. Well, pretend I can actually spell hypotenuse. So hypotenuse is always the side across from the right angle. The opposite and adjacent, though, are always in reference to one of the angles. So the opposite side from A would be lowercase a. The adjacent side would be B. We switched it to angle B just for sake of argument. So for here, this would now become the opposite. This would be the adjacent. And then the hypotenuse is still the hypotenuse because it's across from the right angle and that never moves. All right, that's always what it is. Okay. The other thing we want to review real quick is the Pythagorean theorem, and that's more so just remembering it is a squared plus b squared equals c squared, where c is our hypotenuse. Okay. So if we remember, we have those trig functions that we've seen before. There are the three original trig functions. So there's sine, cosine, and tangent. If we remember SOHCAHTOA, sine of an angle, which we'll say theta. We'll usually use Greek letters for angles. Sine of an angle is the opposite side over the hypotenuse. So the SO part, SOH. Cosine of an angle is the adjacent over hypotenuse. So that's the CA. TOA part is the tangent of the angle is the opposite over adjacent. Okay, so this is SOH for SO, CA, CAH, and then TOA, TOA. Now, we do have what are called reciprocal functions as well. So the reciprocals, oops, reselect the pen, reciprocal. See if I can spell reciprocal right. Yep, can't spell. Let's try again. Reciprocal. The reciprocal trig functions are cosecant, secant, and cotangent. And I wrote them in this order for this reason. Cosecant is the reciprocal of sine. So if you know what sine is, you take the fraction and you flip it. So it's the hypotenuse over the opposite. That is what reciprocal means. Secant of an angle will be the reciprocal of cosine. So it's the hypotenuse over the adjacent. And then the last cotangent is cotangent of an angle would be the adjacent side over the opposite side. Okay, so these are your 6 trig functions. Those are your 3 original, and then these are your 3 reciprocal. Okay, so once you find these 3, to find these 3, you just flip the fraction. Okay, so let's do some examples here. Example 1. we're going to evaluate the 6 trig functions of angle A. So you'll be given some triangle, and we'll always do a right triangle in this class. So you'll be given 2 of the sides. And we're saying angle A, which we're going to say is this guy right here. So right now, we need to find all 6 trig functions, which means we need all 3 sides. And we're finding it with respect to A. So to find the third side, that's why we reviewed it, we're doing a little Pythagorean theorem. So you would set it up as 4 squared plus b squared, well, I guess a squared, but it really doesn't matter, equals 8 squared. So 64 there, 16 here, subtract it over, you get 48, and you get square root of 48, which breaks down to square root of 16, square root of 3. So yeah, you get 4 square root of 3. Okay, so that is what this side is. Now, since we're looking at it with respect to A, this would be our opposite. This is our adjacent, and our hypotenuse will be the 8. So let's go ahead and do all these. So it's sine of A would be opposite over hypotenuse. Now, because there's a root involved, you could simplify the numbers in the front. So 4 over 8 would simplify to 1/2. So then it would just be root 3 over 2. Okay. Cosine of A, adjacent over hypotenuse, 4 over 8, which is 1/2. And last, for the original ones, is tangent. So it's opposite over adjacent. The 4's cancel, and you're left with root 3. So you found those 3. We want all 6, though. So we now need to do the cosecant, secant, and cotangent. So I'm going to start with the cosecant because it's the reciprocal of A. So it'd be 2 over root 3. Now, we don't like roots in the denominator, so we would actually multiply by root 3 over root 3, and we would end up that the cosecant is actually 2 root 3 over 3. Okay. Then I'll keep it this color. We're going to keep moving on. Secant now is the reciprocal of cosine, so it'd be 2 over 1, which is just 2. So there's that one, there's that one. And then cotangent, reciprocal of tangent, which in this case is square root of 3. Well, if it's not a fraction, you put it over 1 and you flip it. But just like with cosecant, we don't like the roots in the bottom, so you multiply by root 3 over root 3 to get root 3 over root 3. So yeah, there's our 6 trig functions. If you're asked to find all 6, you just need to know all 3 sides, and then you're doing some SOHCAHTOA. All right, another type of question that you may be asked is just to find a specific side, right? Now, for these ones, you may end up having to use your calculator, and that's okay. So let me just give you a quick right triangle. They ask for 23 degrees, and we say it's A and 11. So we're not given much, right? We're just given really 2 things, and we're looking for this A. So because we're given this angle, though, we know comparatively this is the opposite side, and this would be the adjacent. So then you think about SOHCAHTOA, and you're like, oh, that's opposite and adjacent. Let's use tangent. Technically, we could also use cotangent, but you'll see why you always want to choose sine, cosine, or tangent if you can. So that would equal, so it's always tangent to the angle, so 23 degrees, and then it would be A over 11, because that is the opposite over adjacent. Now we're trying to solve for A, so I would multiply both sides by 11. So I get A equals 11 times tan of 23. Now tan of 23, though, let me real quick get to my calculator so you guys can see it. Just so we're clear on how to type this in, well, I would say 11 times Here's why we choose sine, cosine, or tangent, because we have those specific buttons on our calculator. Tangent of 23. Now, before I hit enter though, because it's the first time I'm doing a problem today, I always want to check my mode of my calculator. So you'll hit mode, and you can see here that degree is currently not highlighted. So I have to go over to degree, hit enter, because my calculator needs to see this as a degree. And the only way it does that is if you change it to degree mode, hit enter, and we get an answer of about 4.7 for that side A. Okay, so yeah, if you have to find a specific side and you're given one of them at an angle, you just use some trig, right? So sine, cosine, or tangent of the angle equals its corresponding ratio. Solve for that variable. Type it in the calculator if you need to. So 7 point, hard to see that decimal. 4.7, sorry, equals A. All right, last type of example here is ones where they want you to solve the triangle completely. So for these types, you'll be, I'm not moving that around, go back to the pack. For these ones, once again, given the triangle, this one will say is EFG. This is 7, this is 25, and they don't give us anything else. So we need to find three things. We need to find this side, which we'll call X. We need to find angle G, and we need to find angle E. So let's find angle. Technically, we can find any one of them first, but for sake of simplicity's sake, we can find that third side using either Pythagorean theorem or recognizing it is a 7, 24, 25. So it's one of those Pythagorean triples. So this side is 24. So we're already good. Or you could have used Pythagorean theorem, and that's totally fine. Now let's set up some trig functions to help us. Now, because they're all whole numbers and there's no rounding issues, we can do it of any of them. So let's find G first. So angle G is going to be the sine of G. So sine of G would be the opposite over the hypotenuse. Now, this is where things get a little tricky. So we don't know G, but to get rid of sine, you do the inverse sine, which means we do it to both sides. The inverse makes sine go away, but this, we can't get rid of it, but this is where we go to our calculator again. To do the inverse, it's second, then the trig function. So second sine, 7 divided by 25. And because we're in degree mode, our answer is in degrees, so angle G would be 16.3 degrees. Okay, so there's one of our answers, there's another. Now we have to find angle E, and there's two ways. One way is just do another trig equation, right? So angle E, let's do cosine this time just so we can see it. So cosine of E would be, once again, 7 over 25. We do the inverse cosine. So once again, we go to our calculator, and second cosine 7 divided by 25, and you hit enter, and you get the 73, and we're going to round it to 73.7, and there you go. The other way we could have done this one, because we found one angle, we could have also just said, oh, well, it's a triangle. Total is 180. The other two angles we know are 90 and 16.3. Add those together, subtract from 180, you would still get 73.7 degrees. Okay. So thanks for watching, and have a good day.